I'm Kara. I'm a grad student at the University of Florida, and there's a certain amount of frustration I think I feel as a young scientist at how science is conceived. And so I wanted to talk about how scientists actually talk to each other, because believe it or not, there's a lot of communication that takes place, but a lot of it is very opaque to a lot of people. And so I'm hoping that maybe I can translate some of it. And so this was kind of brought on by this thing I saw on my Facebook feed the other day, this little post by Science Magazine. Basically what it's saying is, okay, well, it seems like breast milk actually contains coronavirus antibodies. But then you'll notice that top comment down there says, it's funny, because when you click on the link, it says it's unknown whether breast milk may pass on immunity to the virus. And so the link that you'll see here is not the article itself, not the research, but a little bit digested from the raw data. I think that's really taken out of context, and I'll show you why. But I think first, the thing that needs to be addressed is that academia has its own language, and it's for the purposes of efficiency. Basically, it's scientists talking to other scientists, and we're trying to make sure that our results are as easy for one of our colleagues to understand as it is for us to do. And so that being said, we're not really thinking about how to communicate that effectively to people who aren't sort of working with the same base knowledge. And I promise, people are really working on trying to make science more effectively communicated so that people understand what is being done and why. And so there are these sort of 5 basic principles that I've come up with that try to delve into why it's kind of opaque for people. And the first being that scientists have this language of like explicit uncertainty. So we use words that are kind of wishy-washy. Very rarely do we say things in our articles that are conclusive. And I think people interpret that to mean that it's uncertain, that we don't know what we're talking about. And like, that's just bullshit. We do this on purpose because chances are the thing that we have just produced is a very, very small piece of the puzzle, and someone else will provide a different piece of context later that might change the overall conclusions that come out of the research. But it doesn't mean that what we have done is irrelevant in the future. It just means that in a different context, it might mean something different in the future. And that's the beauty of science, is that it's sort of moving towards truth rather than a declaration of absolute truth all the time. The next thing is that we work with highly condensed language, consisting of tons of acronyms, which are kind of exhausting, a lot of jargon and vocabulary that takes a lot of time to really get a handle on. And then finally, also using citations. So the brilliant thing about citations is that you can make a claim, but you don't have to go on and explain why you think this claim is relevant. Like, you can literally just go and cite another scientist's work. And then if someone is really interested in this claim that you're making in your paper, they can actually just go to the original research and find what they're looking for. So it's really a way of like creating this cool little tree of information, so that your paper contains one little piece, is like one little leaf, but then it's also connected to all of these other leaves on the tree that are all trying to tell similar, if not the same story. So for example, this same paper, the one about antibodies in breast milk, look at all those acronyms. I mean, if you miss where it says secretary component and then in parentheses SC to explain what it means, like if you miss that, you might not know what SC is for the rest of the article, and it's really confusing, but it does save a lot of space. The next thing is jargon. So this section basically has all of these phrases that are not defined in text, because it's sort of taken for granted that the person reading the article knows what these things are. But this does make it hard for somebody who's not familiar with the literature or with the vocabulary to break down some of these concepts. And then the last thing is citations. So like I said, citations, save a lot of space because you don't actually have to defend yourself whenever you make a claim. Like, somebody else has already provided the defense for you, and that's why you're saying what you need to say. And then this paper has about 20 or so references at the end that are cited. Number 3, consistent structure. So there's the abstract, which I will talk about in a little bit in more detail. And the abstract is really important because basically it's a summary of your research. And then the next thing is the introduction. So that's all of the sort of background landscape. You know, these are the things that we understand, these are our hypotheses, and then it introduces the work. And then you move on to methods. You know, these tend to be the most jargon heavy of the sections, just because, you know, you're trying to condense it down, but it's also you're using these really complicated and very specific techniques. It's a whole thing. Then there's the results. Realistically, like all of the results that you talk about should be with reference to the figures that you put into the paper. And then the discussion is where you sort of make connections between your results and other people's results, and then trying to put forth some ideas as to why this is important or what the next step in research should be. And then the very last section is just the supplementary information, acknowledgements, disclosures. So no conflict of interest here. Most people don't really read those, but they have to be there. So this is the abstract that I was talking about. And I'll kind of break it down. So I've got these 6 different sections highlighted. And the first being some sort of statement of the current state of affairs in this topic or a problem being that like this has not been looked at in human breast milk before, so let's look at it. And then the next step should be defending why that's important. So protecting infants and young children from COVID-19 being critical to limit transmission. And then the next step should give you some oversight of the methods being used, the main findings, then talk about the conclusions. Finally, your last sentence will probably say something about like the next steps that should be taken. And so let's think about this in terms of, you know, that thing that I showed you at the beginning where this lady was like, it's unknown whether breast milk may pass on the immunity, right? And got this out of this section. And so this isn't really an abstract per se, but it is trying to communicate science into more sort of common language. But this particular paragraph kind of keeps that abstract structure. Basically what this is saying is like at the time that this study was done, there was no evidence that breast milk might do this or not. Like nobody had looked at it. It's a declaration of the problem that the study is trying to address. So number 2, statistics. I'll be brief on this, I won't go into it, but there are some 3 things. Your statistics should support general trends, not be considered proof or absolute truth of your results, and, you know, using statistics to define quote unquote significance is really to talk about whether or not your results are repeatable. Like somebody else could do the experiment and probably get the same results. Like it is a statement of consistency. So this, for example, is another figure from that paper, basically saying that, you know, antibody reactivity in those breast milk samples is higher when faced with COVID-19 than not. And like the P is less than 0.0001, and that's very, very small. So people, when they talk about p-values being significant of, you know, less than 0.05, it's like saying that there is a less than 5% chance that these results are just woefully incorrect. And finally, third-party fact-checking. Believe it or not, this is really common among scientists and always has been, even though, you know, Facebook and shit won't do it. And it's called peer review. Yeah, so every time somebody writes a report of their research, they send it off, and the editor of the journal they choose either says, oh, this is relevant to our interests, I'll send it out to some reviewers, or, oh, maybe you should send this to a different journal because it's not really reflective of the interests of this particular journal. But if they do send it out, they'll usually send it to at least 2 reviewers, wherein the first reviewer tends to say, oh, this is really great, but may suggest some light revisions. Reviewer 2, on the other hand, might say, no, this is crap. I think you should reject this, like it should not be printed, and I don't have anything good to say about it. At which point the editor will send it out to a 3rd reviewer who may come back and say, no, it's actually okay, but these are the revisions I would suggest. And so one of the reasons why they do this is to make sure that the things that are being said in the article are reflected in very specific things like the title and the abstract, but they also check other things like, you know, analysis methods, whether the statistics make sense, whether, you know, the figures are actually saying what the authors think they're saying, and then they might suggest additional analyses to just make sure. So when we go back to this lady again, who is talking about this, which is not an abstract again, basically saying that this is crap because the title of the article seems to be directly contradictory of something that is in the very first paragraph. And in general, that's not going to be true. Like, the review process weeds out inconsistencies like that real fast. So anyway, so the person who made this post just really kind of missed the ball on that, but it's not really their fault either, because scientific literacy stems beyond actual science and actually goes into knowing the structure of communication among scientists. So I hope this was not super boring. I don't know. I guess we'll find out. Thanks very much.